Warped 1, this one has no. Ito pati na naman gawin. Can you put X? Saya spend the setting.
Thôi xử lắm à? Hả? Thôi xử lắm à? Thôi xử cái hộp.
Oh. A lot of ways. Wonderful. Have both of those, right?
I don't quite understand the first question.
First question is there are n word pads. Each word pad has a setting as I. So word pad I has a certain setting as I. So we'll call it when represented in binary, if one bit of SI is in the same position, how do I say this? When represented in binary, if one of the active bits, if one of the one bit in the binary represented as I is in the same position as one of the active bits of the binary represented as J, then you can warp from I to J where J is greater than I.
Oh. Okay, I understand now.
Where the subtitles? I need to down and draw. It means that everything is fair, so you can go anywhere. You can go anywhere. You can go anywhere. For example, if you have 5. Going here to here, it's 1. Then this should wait. WordPad 1 is in his office. Oh no, WordPad 1 is his house.
I don't see any idea how to solve the first one though.
First one, everything is 0.
Mhm.
So math.
0
math.
is definitely impossible.
No, if 0, then all of its bits are 0. All of the WordPad's bits are 0. So you can teleport from anywhere to it, from I to J, where J is greater to I, no matter for
It
any I.
says that note that the warping between two warp pads using a warp setting of X require both warp pads to have warp setting X active. Does it mean 1?
Oh yeah.
So just
Right.
call, just for the first question, just call 0,
0.
right?
Oh.
Call 0.
Oh yeah, they have to, both of them have to be active.
Just
And
say
since it's
0.
0, there's none active.
Say 0. Yeah, it's 0.
What is it again? The input in N. And see in
What are kind of feelings? Skyline is even easier than this question.
Skyline.
Yeah, the
Then see-
second one. The first one is even the hardest, I guess.
Wait, let me test it out. It's impossible. Oh wait, unless n equals to 1. That's the corner case. If n equals to 1, there's only one way, which is not to travel anywhere. Right?
It's not impossible. N is at least 2.
No. What do you mean? N is not at least 2.
Look at the limit.
Greater than or equal
Oh.
to, it's not. Yeah, so if n equals to 1, then it cannot be 0 because he's already at WordPad 0.
Interesting.
Which is a good. See, WordPad 1 at his own house and WordPad n is at his office. So if n equals to 1, then his house is the office. It's already
Wow.
there. Wait.
His house is the
Else, yeah. Okay. Oh wait. 2 to the power of 30 minus 1. Yeah, that's still integer. It's okay. Yeah. You don't need modulo n again. Yeah, works. All right. So that's 2. Let's see subtask 2. N is smaller than n is that small, as I is until 31 only.
for subtask 2 I can brute force, right?
Yeah. But how? Force. How are you supposed to wait, how do you force this? So let's say we have 3. Yeah.
Just convert every number into binary first, and what's next? Binary string. String is better.
Oh, then we can use recursion, right?
Yeah. We need to
You need to reverse the binary string. You need to convert it to binary. Then reverse the binary string so that we are looking at it from the right.
you don't even have to reverse it because every single string is already reversed.
Yeah, but it's easy to make it reversed. Or we
You
just
don't have to reverse it.
if you want, you can leave it not unreversed.
Yeah, don't reverse it. It saves some time.
Yeah, that makes sense.
You only need to reverse it.
Then we make a
Yeah.
function. We make a function. How do we
You just convert everything to binary.
How do you convert to binary?
You're searching online. Bunch of like functions
yeah.
already provided for you. You just have to copy.
Okay.
And if you want, it's actually very simple. Just constantly dividing by 2.
Convert decimal to binary. Nope. How do I convert? Divide a number by 2 through division operator. Oh yeah, we can do it as a string. What? I equals to I minus 1. Wait, what? I think this is a mistake. Supposed to be n minus 1. No. Oh, wait, no, it's not. Oh, never mind. The mistake. I didn't initialize I. Let's see. Oh, yeah. Yeah, so instead of an array, we can use a string. Oh, and it's already reversed. It's already reversed.
You don't even have to reverse it because every single string is already reversed.
Yeah. Okay.
But what's
Alright.
next? What's next?
Oh yeah, what is next? So we have it in binary. Then we make the function. Now, how do we make the function? We have the function as the current index of the vector.
Oh,
The
a
current
vector of
index.
strings. I think we can convert the binary to strings. That would be better.
Yeah. Then it would be a vector of we'll have a vector of strings. For all strings. And then we have the function with the current index. If is the current index. Then we look through for all yeah, we look through for all indices that are greater than int, because we can only warp to a larger warp pad, right? No. Wait, how do we do this? Oh, yeah, we have a nested loop. We loop through all the warp pads in front of us. And then with all that warp pads in front of us, we loop through all the strings. We loop through the string, both strings. And if there's an overlapping active bit, then we run it. Then we call that function with that integer, with that function, with that warping to that warp pad. Right? Yeah, but that will be
Doesn't it like to prevent infinite loop?
Infinite loop?
Yeah. Like you just from 1 to 2 and then 2 to 1 and just keep swapping.
Oh, no. We cannot go to the back. You see? Where is it?
You also have to prevent that, right?
No. Let's see. He can only travel to warp pads numbered greater than X.
Oh,
so
okay.
We can just loop through the warp pads greater than X, and then we won't be in the warp loop.
Interesting.
Right.
Now what?
If n is smaller than 8, then we have a vector of string. I don't have it. A vector of string B. If n is smaller than 8, then wait, I did not even input the array. in n or in I, if n is smaller than 8, if n is smaller than 8, then I look through. For each I a, does it work for races? Should work for races. Each I a with I a, right? Oh, then we convert it to yeah. So v equals to vector or string and this. If n then equal to it, do this then 0. So we have the v is vector. This is. Let me just use it. For in I equals 0, I smaller than n, I plus plus. Then I look through. Oh, then I convert it to binary. While AI, while AI, while AI should while AI while AI, because while is still 1, v I plus equal if AI mod 2 vi plus equal 1 else vi plus equal 0 I divide equals 2. Yep, then that's all. It's converted to binary, and after that we don't need to reverse it. Sorry. What happens now? Oh yeah, we pick the function. In func, in current, interest equals 0. For let me try using this. I'm not used to it. I for in I equals to current plus 1. I smaller than n. Make this slower. In n. Okay. So I look through. For in j equals to 0, j smaller than mean of size of v current and size of vi, that's that. If v current j not equals, that's plus equal, no, we want if it's equal. V current j equals to vij. If it's equal, rest plus equal func I. Func if current equals to n minus 1, return 1. Short func 0 backslash n. Okay, let's try something else. 5 maybe? Let's try 5. 5 5 2 1 3 4 5. I don't know what will be the results. 2 is 1 0 0 1 0. So 0 1 0. And then 3 is 0 1 1. 1 is 0 0 1. 4 is 1 0 0. 5 is 1 0 1. Right? Then what do you want now? Oh yeah. So from here, from 1 we can only go here. Oh wait, I forgot something. If v current j equals to that, and v current j equals to 1. Enggak. Cek dulu. Zarit. Zarit. Okay, so we can only go there. And then if the active video doesn't really matter. So we can either go to the end or go in front of it. So that's one path already. Oh, there are only two paths. Oh, one.
I don't get it.
What? Rest mod equal mod. Why is this? Wait, let me try see out each IV. Yeah, I. 0 1 1 1 1 0 0 1 Kamu ikut coding ya? What is this? Cara mau ikut coding? Oh wait, oh my god, of course. If it's until 31, what's 31 in binary? 31 in binary. 1 1 1 1 1 1 1. So it's 35. You can just do for in I equals to 0. For I 0 5 1. For I 5 actually. I could just do for I 5. Okay.
Wait,
Yep. Or rep. Oh. Repeat. I till 5. Then it becomes like it should be 2, right? Because you can go from here. You can go from here. You can go from there. From the first one, you have to go here. And from here, you have to go. Oh, wait.
What's the
Wait, it's
time
only one.
complexity here?
Oh, it's only one. Wait, is it only one? Am I looking at it wrongly?
What's the
One
time
is-
complexity here, Diti?
Is it? Oh, it's in. Is it in? Yeah, I don't understand. There's something wrong here. What is wrong?
Are you still at the converting part?
Yeah, there's something wrong with the conversion.
Hmm.
10100. It should be in no, this is correct. Right, this is looking for the back. So it's 001. Then there's 01 1100. 1000. Wait, 1 2 3 4 5. Wait, did I calculate it wrongly?
Wait, Oh, this is very
Oh, it got. Oh, it's missing one. It's
Uh-oh.
missing 00000. It's missing 3, or maybe 3 is just in the wrong position. When I equals to 0 is and rep. Oh, rep J has to be J. Oh my god. Yep, it's still wrong. Something's wrong with the conversion. There's something wrong with the binary conversion part. Enggak ada ngapain. For in I equals to 0, why is this not working? There's something wrong. Or did I calculate it wrongly? Wait. 3 is. Oh, I calculated it wrongly. Oh, wait. Or am I looking it down? Yeah, my fault. This is my fault. 2 should be 010. 1 should be 001. 3 should be 011. 4 should be 100. 5 should be what should 5 be? 4 plus 1, right? It's the 101. Yeah, I calculated wrongly. Never mind. It's my fault. So one path only is from here, and from there that's only one path. Yeah, so it's only one. It's only one. Yeah, count is correct. All right. Modulo M already. All right. Nope, still wrong. What is the same as chess? And smaller than or equal to it. Oh, it's smaller than or equal to. That's one mistake. Is there another?
Wait, let me think.
What about you? What has?
I kind of no idea what's going on.
Is 5 really correct?
Wait,
Yeah, that's correct. Ayah, ayah, ayah. Hmm. It can still be 0. Yeah, it can be 0. If v current equals 0, return 0. Oh no, I cannot check that. What? Why is it? Maybe what if it was just that single? Oh, what if I no? What if I make everything wrong? Long.
kind of figure out what's wrong now. I think I got it. The
Okay.
binary pi, I got it.
Yeah, I got the binary part also, but what about the function part? Have you gotten the function part?
What are you doing? Huh?
What?
I don't know what you're doing right now, you know.
I'm trying to solve subtask 2 of warp.
Oh,
What about you?
did you manage to solve the function part?
Yeah, I think I got the function, but it's wrong. Function's wrong.
Oh,
So that means there's one way here. There's one way here also.
interesting.
One. Oh.
Wait. What's the time complexity if you want to solve this using the brute force method?
Time complexity it's O(n), then this is a set number, so O(n) squared. Yeah, O(n) squared. O(n) squared where n is at most 8, that's okay. Right?
Wait. I just read something.
Yeah, what do you realize?
It says we can only move forward, not backward, we can use DP, dynamic programming. Can we?
Yeah, we could, but then the tricky part is the binary. Is binary, right? How do we check that two how do we check that the two word pads have the same active bit, right?
It is hard.
Oh, never mind.
What is it?
What if we try subtask 4 first? Si equals to Sj for all ij.
Oh, then that's like what
Can use dp, right?
no idea. Yeah, I think we can try to solve subtask 2 first.
Yeah. All right, 2 first. 2 first is brute 4, right? Brute 4.
But the thing is that you still need binary for that.
Binary, we can just convert it to a string. Put it in a string.
Yeah. Oh wait. Wait. Yes, there you go. There you go. What's next?
Subtask 2. How do you do subtask 2? How do we do subtask 2? How do we do subtask 2? Is there a trick? Is there a shortcut to find where the two numbers have overlapping bits, have a same active bit? XOR, XOR. Wait, XOR does what again? I'm confused about XOR. Complicated one. Oh, it's whether, so if 0 and 1 returns 1, 1 and
If you want code to be 1, then you have to put n. Not XOR, n.
then XOR is when I want,
N.
then XOR is when I want both to be 0 and 1.
XOR is when you want only one of them.
Only one of them is 1. I want both to be 1.
N. Equals n.
Oh, yeah. Oh, we can use, oh, I forgot.
What
about
is
that.
it? What happened?
We can use bitwise operations.
Huh?
Bitwise operations. Yeah. We don't have
I
to
don't get it.
So in in C++ there are bitwise operations, right? And or XOR whatever, right?
Yeah.
Yeah. So the
You want to convert the binary?
what? No, we don't. They already have it as binary. It's stored in the computer's memory as binary. So when we use the bitwise operations, they'll use the binary represented integer and compare it. So for example, there is a binary operation and just one parenthesis and. Usually it's like address, finding the address or something, but it can also be and as in something and something like 3 and what else? 3 and 1.
But how do you compare whether there's one active integer, both active integer there?
Yeah, and do you know what n does? You know what n does, right? You know, logic gate. Yeah, that's the biggest N.
Okay. So you can just use N. Okay. Now I got it.
If VI and VJ, VI and no V current and VI. Wait, then I don't need this. Okay,
Let me
so
see warp. Limit is quite big.
don't need this. Yeah, see 1. 3 and 1 is 1. Because it is. What? V current and VI. Why is this wrong?
Oh,
What? Why
this
is
is DP, right?
yeah, this DP. What's this wrong?
DP where from one pad to another pad, the count is number of equivalent one bit.
No, just whether there is an equivalent 1 bit or not.
So you need to multiply. Because if there are multiple equivalent one bit on the same position, then that's how many different ways to mark
Yeah.
between the two pads. So what do you need to do now?
I'm trying to reconcile.
If n equal to n minus 1, why? Why if current equal to n minus 1 return 1?
Then it's reached the end. So that's one method.
Oh, this is zero index, yeah. N is the number of pairs.
Yep.
It's an input, yeah. Oh, okay. What is SI?
SI? Where?
What is SI?
Where do you see SI?
Settings, yeah.
Hmm?
SI is the setting.
Oh, that. Yeah, this is it.
Say, Mas, you cannot do this, right? This is, you cannot just chop the finish greater than 0.
If something's, yeah, you can, right? If there is an active bit in both of this, in both V current and VI, then having the AND operator, it will return that 1 bit still in the same position, which means that it will have a value and not 0. Where 0 is everything is 0, so none. No, I think it's together.
Every one bit, every mutual one bit partition gives you one different way. Right? Correct.
No.
Yes, correct. Like in the example 19 and
So really?
this one. This one. Note that each work setting provides a different method of working. So working through one setting, meaning the bit position, is different from working through another setting, meaning through another bit position. Even if you work between the same two objects. So if you work from, let's say, 3 to 7, 3 to 7, there are two ways to work from
so
3 to 7.
find how many ones again.
Exactly.
Oh, how do you do it?
Then finding how many one bit is right. So one thing you can do is just continue divided by 2. It's shift. It's shift divide by 2. It's shift. If you divide by 2 for both numbers, and then just compare the modulo 1 and modulo 2.
Divide by 2 for both numbers.
Or you can do and also and then the resulting and you calculate how many one bit there is.
How? How do you calculate?
You continue dividing by 2 and then dividing by 2.
Oh, okay, I see. So we have in res equals to V current and VI. Probably. Oh yeah. If res is greater than 0, then while res, is it while res? Same thing. Okay. We do not need this. Oh yeah.
So why is the plus equal function type?
Yeah, plus you're adding the number of paths there is from I to N. Recursive. It should work for subtask 2 at least. Even for subtask 1, that means wait, subtask 1 is yeah, all S are 0. Oh, Sn equals 0. Oh wait, what? Sn equals 0. Oh, Sn equals to 0. Oh, I thought Si equals to 0. So if Vn minus 1, if Vn minus 1 equals to 0, if n equals to 1, okay. Yeah. Subtask 3 is basically Yeah. All right, let me try DP. How do I do DP? DP one state only, right? Only one state. Yeah, only one state. How do I do this DP? Ow. F0. I'm at 0. Okay, let me try DP. So yes, in DP0 equals to 1. DP0 equals to 1. Then what do we want to do? How do we do this? Do I have to look through the previous? That would be ON squared. ON squared. 1,000. 1 million. Oh, 1 million is still okay until here.
Have you solved the first question yet?
No, not yet. What about you?
Have you solved even a subtask yet?
Yeah, I've solved subtask 1 and 2.
Yeah, 1 is easy and 2 also. I'm trying 3 for now.
Okay, I'm also trying 3. 3, I think ON square could work. That means I can for in I equals to 1, and I plus dpi equals to 0. I can set this as a vector. Vector ln dp of n 0 and dp n equals to 1. I don't need this. For in j equals to 0, j smaller than I, j plus plus. Wait, I made shortcuts for this. But now, for in j equals to 0, j smaller than I, j plus plus. That's looping through from the back. No, this would be O and Q. I know, let's just try first. Wait. This is not really BP. Oh yeah, this is BP. Here BP and minus 1. Then you remove this first. Let's see how it works. It works, nope. It doesn't work. It's missing one step. Each IDP CL I what should be 11248? Oh my god.
I don't get it. What is wrong?
Yeah, that was the problem. So if
Oh,
what happened?
I just realized something.
Yep.
Like you see, if the setting was 3 and 3, there are actually two ways to switch between these two settings.
Yeah.
But our program, if we use and, it will actually you can actually say as 1 only.
Yeah, that's why. It's not. Yeah. So what then I did was I manually looked through the binary after the n, and I count how many bits there are, and for each bit I add the answer. Yeah. That was a mistake. Fine.
So we just cannot, like, oh dear.
I'm trying brute force. Oh yeah, I got until sub 3. Everything
Okay.
else is. I think this is DP. It's DP, but then the problem is. Okay, so subtask. So Chen William, where are you at right now?
Still at subtask 3.
Subtask 3. Okay. Subtask 3, what I did was brute force, DP brute force. It's ON square. ON square would work. Or maybe it's ON cube. No, it's ON square times 30. O30 n squared, but 30 is a constant, so just remove it. So it's ON squared. ON square would work with 1,000, with n at both 1,000. Let me try. Si equals to sj for all ij. Si equals to sj for all ij. Oh. That means that we just have to get the power. Yeah. Oh no. If si equals to sj, what we can do is count the number of ones in si or in si, whatever I is. S0 actually. S0 is best. So we count how many ones there are in S0. Then we get 2 to the power of n. No, 2 to the power of n minus 2. Yeah, 2 to the power of n minus 2 max. 2 to the power of maximum 0 n minus 2 multiplied by, and wait, let me try something. What if it's 3? What if it's 3? So it's 0, 1, 1. So it's 1, 1. That means that first over here it will be 1. And then over here, because it's 1, 1, you can go 2 times 2. Then over here, because it's times 2. Yeah. So let me try something. Bool subtask 4 plus 1. If vi and vi not equal vi minus 1, that's why it goes to 0. If subtask 4 let's use this DP approach. So LL current equals to 1, right? Then I multiply by how many? I can multiply by the count. So what I can do is LL num equals to V0. Right? Then I just do this. count equals to 0, going down. Count plus equal rest and 1. Rest and 1, right? Rest and 1, okay. This is just num. Bring this up. LL current equals to 1. Repeat I till n. But I want to start with 1. So it's for I1 and 1. I1 and 1. If I nope, let me delete this one.
There is only one.
So DPI equals to current time count mod m mod m mod m mod m. Let me just change this mod. M is better. Shortcut. Mod m. DPI equals to current mod m times counts mod m. Then current plus equal DPI. Okay, let me try something. 5 3 3 3 3 3. It should return 1 2. That's 3 times 2 is 6. That is 6 and 9. That's 9, but that becomes 3, so 27. Then is times 27, 56. 56 times 3, then we have 2 is 72. Should be 72. Or did I calculate wrongly? No, it should be wrong. I calculated wrongly. Let me try something. Each I dp c out I. 1 2 6 18. 18. Oh yeah, I calculated wrongly. Oh my god.
Okay, now I got subtask 3.
Oh, nice.
Now how to solve 4?
For the special case, is what's special about 4 is that Si equals to Sj for all ij. So you can just you can still use dp, but it's simpler now because you know that any word pad can travel to any other word pad greater than the previous word pad, right? So you can just
Still use DP.
Yeah, still use dp. Just you can make it faster. Yep. Oh, never mind. I got wrong. Why? Oh, current is already more than that. Count is constant, so we can just do count as equal that, then count what equal m. So we don't need this. 1 millisecond. This one here. What? Why is it slow? And why is this too slow? This is too slow. SI equals to SG, is that faster way? Because this is ON. No, this should be ON. Yeah, this should be ON. Right? Is it, or is there something wrong with my some task bar checking? Let me try something again. TLE. We need to make some task more faster. What is the relationship? 1 to 18? If it was just 1, then it would be 1, 1, 2, 4, 8. If there were 2, then it would be 1, 2, 1, 2, 6, 18, 54. But it's TLE. Why is it TLE? Oh. Oh, of course. Let me try again. Yep. Okay, now just subtask 5. It's just subtask 5. DP.
Oh, both 3 and 4.
3 and 4. Yeah, but 4 was faster because it's ON. 4 I can do it in ON. Since yeah, I don't know if this DP. I think it's just brute force. Right? I look through for all and I look through from the back. This still brute force. ON square. This ON square. It works until subtask 3.
ON square. And until what? Until what?
1,000. I mean 300,000. But this one works until n is 1,000, which is subtask 3. Subtask 4 is n is 300,000, or with what? 300,000. 300,000, but SI equals to SJ. Yeah. Then you can do it in ON.
Equal, then just calculate once and then
Because yeah.
yeah. Okay. Subtask 5 no more constraint.
No more concept.
Subtask 5 apa?
Just
And it's 300,000.
300,000. Yes. Which means that it has to be ON or ON log N.
Mungkin ON. ON log N.
I think
So-
this is the right approach. This is the right approach. This is like Candy Mountain EX, but from one stone to another, that is the requirement.
Can the GP be ON log N instead of ON square?
How could it be ON log N? For I1 and ON log N.
Or is there a math formula?
I feel like that is a is there any math formula? Is there a yes, the bits. How can there be a math formula?
Given a set of numbers,
Yeah, where are you going?
Huh?
Where are you going?
cannot be n square. 300,000 cannot be n square. Yeah, come on. Yeah, SBO or on. But then how do you do that there? There are n square possible warping, right? Not fine.
Yep.
How do you narrow it down? Yeah. You want to try other problem first?
Yeah, okay. Okay, Chen William, where are you at?
You solved subtask 4 yet?
Yep.
How?
For subtask 4, if you write it right, you will realize that DPI is equal to the sum of DP0 up until DPI minus 1 multiplied by the number of ones inside the number of ones in the bit.
Oh, now I get it.
Yeah.
That's easy.
Oh, yeah. Yeah. That's right. Okay, skyline. Let's try skyline. Yeah, and where it's all buildings in a row, level 1 to end from left to right from this one. While during the building, I wanted to note down the exact heights of the end buildings. Left and notes. The first building LI, taller than building I. Oh, that is interesting. So for each building, we only have left and right. Left. First left tallest. So the first, it has to always be minus 1.
Wait.
If multiple answers exist, no, there's only one. Yeah, multiple answers can exist. Okay. How we do this? If we start from the tallest, what happening if you are at the tallest building, you look left, minus 1, you look right, minus 1. So tallest would be minus 1, minus 1. You can find the tallest easily. What if we try this first? Li equals to minus 1. Let's try subtask 1 first.
Wait.
Yep.
So I found for subtask 4, I actually found the number of ones in every setting. So what's next?
Oh, you don't need to find in every setting because they're all the same, right? So you can just
Yeah, I
find.
know, right?
Yeah.
So I just
So-
found that, and
Yeah.
then what? And then what do I do with it?
So
It's a kind of formula.
so you just take note of the current sum, right?
Yeah.
And then you take note of the current sum. You look through the DP array, and then you get DPI is equal to the current sum multiplied by the number of ones, because you can multiply by the number of ones modulo n, because you have to modulo n, right? And then you add the answer of DPI to the current sum, and then you modulo n, of course.
Okay. Now I got it.
I'm trying Skyline now. I don't know how to do subtask 5. We'll go back to that later if we can. What time is it? 3 hours left. Li equals to -1. That means that building I is always smaller than building I minus 1. Where I is greater than 0. Oh wow, this is easy. Subtask 1 is easy. Okay, let's try this. Subtask 1. CNN in N, CNN in L, in R, C in no. VI, L, N, R, N, in L, I. What do you do? Rule subtask 1 equals 1. If Li not equal -1, subtask 1 equals to 0. If subtask 1 or repeat I n plus 1. Oh no. For I1 n plus 1 1. Count I count n. Let's try something. That means it's 1 2 3 4. Let's like 5. 1 2 3 4 5. 1 2 3 4 5. That means it's -1. And then is it 1 based or 0 based? 1 based. -1, 2, -1, 3, -1, 4, -1, 5. -1. It should be 1 2 3 4 5. Yay. Subtask 1. Oh wait, what's the 500,000?
Skylines have been. How many subtasks have you solved yet?
Skyline?
Yeah.
Not yet. I just started.
Oh,
What about you?
me neither.
Okay. Subtask 1 is simple.
Any idea?
Oh, subtask 1 is very simple.
Just 1 2 3 4 5 6 7 8 9 10. Like that.
Yeah, like that. Yes.
Very simple.
Then subtask 2 is 2 until it's it's very small. Subtask 2 is very small. So we can brute force. Right? We can brute force. How do we brute force? Oh, what if we check every permutation and we check if it tallies with the conditions? That would be fun. I think there will also there another way? Based on the conditions. So oh, actually, how do you? Wow, I have no idea. Okay, let me try subtask 2. Just loop for every permutation. Okay. Does it return? In best, why best? What is this? Oh no! Oh wait.
你们今天是 code breaker 还是卡 d 噻？
Code breaker.
哎，我怎么没看你上面题目呢？submission
那不是谁？这个是谁？这是谁？
10分50，
请问这个是谁？
做了几个题目出来了？
哎，待会再说。再做一个 subtask，再赚个18分。
好的，好，哎，有个 scoreboard 看。
是。
那你先做吧，我们先吃吧。
你们先吃吧，我不吃。
啊？
我现在不吃。
我们先吃吧。
Which represent the lexicographically smallest possible permutation. Okay, I did not see that. Alright. There will definitely be -1, -1. Somewhere. That would be the largest.
Why?
Okay, so we mentioned this one. Hmm. Why is it? Yeah. Even a permit system. Okay, I'm just gonna see the next question. What have been trying to do?
How many questions you solve?
It's zero.
I mean subtask.
Oh, subtask. I've solved four. I solved five. Yeah, I solved five.
For the skyline, you have no idea how to solve, right?
Yeah, I have no idea how to do it. I'm so confused. We can just look
Hmm.
through the permutation, but how do we check if it tallies with the conditions? Right? Okay, let me try colorblind. After finishing his design, suddenly that some of the pixels had colors that were very similar to each other. He defines two pixels to be k similar for a positive integer k. If the maximum difference in red, blue, and green values between the two pixels is at most k. Max. Oh, max. Okay, x is the absolute. Same color. Two pixels. If there exists some sequence of adjacent pixels, I am so confused. Being a single is Cj. Anyway, for each j, if there exists two pixels in the design, which are Cj, confusing. This is an interactive problem.
Any idea about colorblind?
It's so confusing.
Yeah, I also don't understand what does it even mean. I'm getting crazy. Well, I am crazy.
I haven't even eaten. I'm gonna try something. This number on the outline being J. So we have a grid of pixels. Servers. Is that how it works? We have a grid of pixels.
just connect from here to here, and what do you get? Well, in here. Well, yeah.
Wait, so that is the pixels. That is.
6.
Oh wait, what happened? Why did it print? So 424247477000000000. Wait, we have an image H pixels high and W pixels wide. What is this then? What is this? 424747. That is RGB. Oh wait, what? Wait. First line will be HWQS. Next H lines of input will contain WL. Oh, that's R, then this G, then that's B. Then this is the query. Oh, I see. You just have to say no or yes. You just have to say no or yes.
Is it what's it?
You just have to say no or yes. And we have to with the okay, this is so first is hit W is smaller than or equal to 2, or this either 1 or 2, that is only 1. So something like this. And how do we check? How do we check if no or yes? How do we check if and find something we can find? So defines to be source A, B, and C, B to be taken up using this exist some sequence of adjacent pixels. Okay, I think I know. All right, let's try this. Download attachments. Colorblind.zip. How do I do this? Colorblind. Oops. Colorblind. It. That's done this. Why did I not? Okay. What should I do? Oh yeah. What am I supposed to do? Wait, what did I want to do again? Oh, init. So we need init and we need bool query. Void init. What are the parameters? In H in. We just copy paste this. That is incredibly long. VLL. 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 So this is init, and then there is inquiry long CC LLC. Then 0. Now init what we can do is make our own vector of vector R, vector of vector G, vector of vector L. Where do we do it? Here. So we have a vector of VLN R G RGB. R equals to R, G equals to G, B equals to B. Then we have in H, L, H, W, Q, S. H equals to H, W equals to W, Q equals to Q, S equals to S. Yeah, this is okay. Is that in it, the song?
Is what?
Pick part
color?
unless I want to do some pre-computing. Now since H equals okay, if H equals to 1 or W equals to 1, see out no, or I have to return. Wait, what? Return what? True if there exists. Oh, it should be bool. Return true if there exists and false otherwise. Return 0. If any of those are 1, then I return 0. What now? If that means that they're both 2. What happens if they're both 2? How do I check if 2 what if I make a function? Can I make a function? Yeah, I can make a function that tells me whether these two cells are k-similar. So bool k-similar. Where is k? Are we given k? We are not given k. Next line will contain q spaced integers, the ith one being c. Wait, then where's k? How to check if something is k similar? Or to be k confusing, if k, bool k similar, I need a k, LLK. Then I need the two indices. LLI G LLJ no LLI1, LLJ1, LLI2, LLJ2. LLK I1, J1, I2, J2. What now? The K similar. Oh, we have to check the K similar. Return max of, okay, let me just get this. Absolute of R, okay. Max of this, that smaller than or equal to k, or equal to, right? Smaller than or equal to. Max if H equals to 1 or W equals to 1, if K is similar, oh wait, oh, I got an idea. I don't know, this is confusing. This is confusing. So we want to find a chain that is K similar except for the X. The problem is K is not a constant. K is not for K is not the same for all the primes. K is a query itself. Which means that yeah. I'm just gonna do this next time. Oh my god, please. Alright, G equals to G and G equals to B and G equals to X. What about art swap? Oh wait, Rij equals to Gij equals to Bij equals to I plus J. That means that it's K similar except when K equals to 0. So it is possible. Yeah. Okay, let's try subtask 2 first. Let's try subtask 2. I'll comment this out. Rij equals to Gij equals to Bij equals to I plus 1, which means that yeah, which means that the absolute difference between two adjacent cells will always be 1. Which means that everything is K similar except when K equals to 0. So let's try something. If C equals 0, return 0. All right. If C equals to 0, then return 0. What else? If C equals to 0, return 0. Another test case, another case where we return 0 is when is when H equals to 1. Is when H and W smaller than or equal to 2. But H and W are not equal to 2 at the same time. Yeah. So if H smaller than or equal to W, H smaller than or equal to 2, and W smaller than or equal to 2, but not H equal to 2 and W equals to 2, then we return 0. It's not little much. Let's test this out. I'll have init. I don't need our space in main later. So I have init. Let's have a test case. HWQS something. HW US oh, I don't know. Let's submit this. Let's see if it works. Nope, forgot something. Oops. I have to add include colorblind.h at the top. Hmm. Yeah, never mind. It's too confusing. Let's try R swap. What are you doing now, Chinwe?
Still trying the skyline.
Oh, sure. Oh, Skyline. And what's your current progress?
No progress. Only +1.
Hmm. Dua. Hmm. There aren't any really helpful special constraints. What now? How do we actually do this? We also want it to be the lecture program smallest possible presentation. How do we find a one valid permutation? First. Okay, let's do this. Hmm. Hmm.
不要放，把椅子拉，把椅子放这里。
This is hard. Oh, n equals to 1. N equals to 1. Let me try. In N, Y. VIP N plus Y. P N plus Y. And M N. Rep
Do you have any
I-
progress on the color blind?
No, none so far. Why?
Just asking.
Yeah. This is getting difficult.
I still can't solve the task for a warp, you know. I don't know how.
Oh, then we should look on that. Can you share your screen?
I don't know what is wrong with it.
Can you share your screen so that we can fix?
Wait up. So this is the whole part.
Oh, use roughly. Okay. If equal, x equals to 0. For in I equals to 0, you settings. Oh, you convert it to. Oh, you convert it to string.
Yeah.
You know you don't need to do that, right?
Doesn't matter, right?
Yeah, actually it does matter. Right? Okay, I don't know that. I do not know the terminology. Never
So
mind.
what is wrong with the algorithm?
In sum equals to 0 for in t equals to t times x mod m mod modulo mod sum equals to sum t. Yeah, sum equals to sum plus t mod sum equals to sum plus t mod okay, makes sense. Oh no, you don't see out the sum is not the answer is t.
Huh?
The answer is t. Okay. Wait. Yeah, sum is not the answer. You do not want the sum. You want the prefix sum up until point I minus 1, right? And then
I think I figured out something. Oh yeah. True though.
the sum is, yeah, I think you can fix the rest.
Mm-hmm. Yeah. Not a sum. It's a T. True.
Okay. If n equals to 1.
Are you thinking of going for the next one? Like, I
That's
mean,
fine.
not colorblind, art swap.
Or art swap, I haven't seen that. I'm
The
trying
next
Yabit.
one. If you can't solve colorblind, you just switch it to you.
I'm trying Yabit meetup. You can try art swap. Then you can. Yeah, Yabit meetup task 1 is very simple. I think. There's
Of
only one.
course. Every single subtask one is for batch is easy.
For best is easy, yeah.
Yeah,
Right.
for me, I think I kind of feel the batch is easier. Way
Mm.
easier.
Maybe it's just easier because we are not used to interactive yet. I haven't done much interactive problems. That's why it's confusing. Oh,
Wait.
yeah, bit meter n equals to 1. That means there's only one elder. So what what are we supposed to output? Compute the minimum amount of inconvenience. Traveling takes time. So what happens is every single Yabit will go to X, for each X, they will go to X, right? And then travel, which will get everything which is direct. Then all the Yabits will teleport will travel to exactly one of the houses of waiting. To note that this will happen. Yeah. Skyline Satas 2 is possible with trying all permutations. But how do we check if the permutation tallies with the conditions that are given? Right? Oh. Oh.
First of all, by giving all the numbers, you can find the number that is both -1 on the left and right side. That is obviously the tallest
Yeah.
building, right?
Yeah, but how do you advance from there?
Yeah, how? I don't know.
Also don't know. Yeah, I'll try let me see. Let's see skyline. So task 2 we'll look through all permutations. How we check? We check for in I equals to 0, I smaller than n, I plus plus. If li okay, so what we can do is for in I equals to 0, I smaller than for in I equals to 0. No. We look through the left. For in j equals to 0, j smaller than I, j plus plus. If li, so li if left I. Yeah. For in j equals to I minus 1, j greater than or equal to 0, j minus minus. Looping there. What happens? Hmm. How do we do this? If Li not equal to minus 1, what is answer? Oh, I do not know. If Li is not equal to minus 1 and I equals to 0, break. If Ri not equal to minus 1 and I equals to n minus 1, break. Right? So now we're looking through the left. If Li oh no, that's not one. If ans J, do I have V already? No. If Vj is greater than Vi and Li equals to minus 1. Wait. And minus 1. Like equals to 0, break. Or in J equals to I, if Vj greater than Vi, if
Hmm.
Vj greater than Vi, if
I
Li
J K L
minus 1,
P.
black equals to minus 1, break.
Sum is 1.
Else else if Li not equal to Vj, with Li not equal to J, break. Plus 1, yeah, plus 1 this. Flag equals to 0, we still have to break anyways. Okay. That's if Vj is greater than. Else if Vj smaller than Vi, right? If Vj is smaller than Vi, if Li equals minus 1, continue. Else if
Oh, wait. Huh?
yeah, yes.
Now I kind of think I'm getting even more problems.
Oh, for what?
Yeah.
Can you share your screen again?
You said that the answer is T. But
Can you share your screen? So
Okay.
the problem is
I did call T, but it's still wrong.
why can't you use the DP at the bottom here? Yeah, at the bottom of your code, you have a DP, right?
What do you do?
So instead of having DPI equals to looping through looping through all of J before I, right? All of DPJ before I. Instead of having to do that, you have all the settings as one specific number, right?
Mm-hmm.
So you can set DPI equals to prefix sum or equals to the sum of all DPJ where J is 0 until I minus 1, right? You get that sum. Then you multiply by counts because from each of those J word pads, you can jump to word pad I count times. Or in
Oh,
T types, right?
okay. Can I
Yeah,
see your
so
code? What do you do?
my code, let me see. Code. Continue. My code is very simple. I just have I just have the DP. I set the 0 equals to 1 because there's only one way. Then I count the frequency of 1, the frequencies of 1. Then I loop through. It's like my normal DP, right? My normal DP, my brute force DP. But instead of looping through the previous J from 0 until I minus 1, I use a shortcut. I use the current sum multiplied by count, right?
Oh,
Modulo M, of course.
and you got it. Okay.
Yeah.
So if equal, I'll just shove this above. And there you go. Hmm. What is CNT? What is count?
Count is the number of ones inside the
Oh, that one.
Yeah.
That's what I did.
Yeah, that's what you did. But you printed counts. I mean, you printed the sum.
But I converted it in string.
Yeah, you converted the string. Actually, that step is unnecessary. It's not so important, but it still works. If you want to use it, it still works.
But it helps you to like help you understand a little bit more. Like simplify the code a bit.
No, simplifying, I don't think so.
Really?
Yeah, because you could keep it as an integer, and you can use the bitwise operations, right?
Mm-hmm.
That's one way. It's usually shorter, but then sometimes converting it to string is shorter. There's what case? Yeah, not for now. Doesn't matter actually.
Yeah, it doesn't matter a lot.
Okay, so Yabit method, we have one leader. All of those is connected to all the Y. Then they all go to that guy. Pay respects. Then they will travel to exactly 1. They will all go to X, and then they'll travel to one of the houses. Then you want the least sum, inconvenience sum. So, but then there's only one X. Wait. You can't really choose anything, right? It's for each X. Oh yeah, because X is, for this case, X is 1. Yeah. Then we get the sum of the weights and plus the smallest, the least messiest house. Yeah. So what is T? T is the time, right? Yep. Any wabi Ti seconds to walk in either direction. Oh, but they still have to walk to that person's house. Oh, yeah. But I can get this first in n equals to 0. N plus equal to Ti. Ti. Right? They all go to X. And they go back to the minimum guy. Int min val min pos equals to int max. Actually, I can get this as m0 0 for I1 and 1 if mi m pos. Yeah. Ans plus equal mi m min pos plus t min pos multiplied by y. Yes, ans backslash n. So right, m min pos Messi level plus t min pos times y. Time gets to go down. Yep. So let me make a test case. N and y are n has to be 1. Let's say there are 3y only. Then what is this? So this number. Next line of input will contain y. Oh no, n plus y contain pi and ti respectively. Will contain pi and ti respectively. Wait. So you gotta at first there was the original orbit. Wabit 1 has no variance, this will be right. Wabit has a house for each Wabit I to have a single director ancestor Wabit Pi, where Pi is smaller than I. Oh, ancestor. Oh, so if n equals to 1, then Pi will be. Oh, but it will be a Yabit. Ancestor could be a Yabit. From Wabit I's house to Wabit Pi's house, which takes any Wabit Pi records to work in either direction. I am so confused. Wait a minute. I'm so confused right now. Oh, it's zero base. Is it zero base? Wabbit 0 is the original. Oh, Wabbit 1. Wabbit 1 is original. They have no parent. Wabbit 1 has no parent. Pi equals to -1 and T1 equals to 0. Will always be like that. One to three, six,
Okay.
4. Oh, I understand now. So that is the parent.
Come on.
That means number 1, there should be -1, 0. Then parent will be parent should be 1. Parent will be 1, 2, 2, 2, 1. Parent is 1 times 2. Parent is 1 times 3. Let's say messiness level is 4 and 5 for each respectively. Yeah. So the answer should be 2 plus 3. Two plus 3.
Come on.
Yeah, but it's not necessarily the lowest, right? Yeah. Oh wait, this is okay. That means in answer equals to 0 in val. Yeah, which means that min val equals to m0, min pos equals to 0. In current equals to ans plus mi plus ti times y. If current smaller than ans plus m min plus min val. Oh, I just need to pause. Plus m pos plus t pos times y. Then pos equals to I. Answer equals to I pos. Then you should see out 2 plus 3. Then plus 2 plus 4. 2 plus 3 is 5 plus 2 plus 4 is 6. Should be 11, but why is it 10? Or is it other way around? There's 2 and 3. Okay, let me run this. Oh, it's that. What? No. Oh, of course. We need another one, 1, 4, for example. 4, 5, 6 then. 4, 5, 6. Let's have 4, 5, 6. Then drawing this here, we'll have the parent. Then we'll have this 3 here. We have 1, 2. So this is a weight of 2. This is a weight of 3. This is a weight of 4. Then the messiness levels are 4, 5, 6 respectively. Right? So that means the minimum is 2 plus 3 plus 4 plus 2 plus 4 equals to 5 plus 6 plus 4 equals to 15. It should be 15 after this. Nope, it's 13. Why is it 13? Yep, answer at first is correct. Then it becomes 13. Wow. Wait, what happens if I do this? Yeah. It's 4. Why is it 4? M pos. plus t pos times y. I am so confused. Ah. T pos times. Oh. Yeah, yeah. Of course. Yeah. Should be 15 now. Nope, 19. What? Is it 19? Oh, it's blue color. Why is it 19 now? Shouldn't be 19, it should be 15. There's an extra. Ah. Okay. No, still no. Should be Y. Oh, it's 18 now. Why is it so confusing? Oh. I can replace that with that. Cancel off ans for both sides. This is it. Why is it? Let me print out pos first. What does pos written? Should written 1, yeah. It should written 0, right? Return t pos. Should t pos 2. Wait, what? Oh, so it's already plus n, is it? Is that what it is? It's already plus n. Why am I so confused? Oh my god, of course. That is why. Why did I make so many mistakes? Still wrong. So written 9, which means that there's an addition of 10. M pos plus T pos plus N times Y. Did I calculate wrongly? Wait, let's look again. Oh yeah, because I added an extra element. So the answer should be different. So I have 3 children. There's 3 bits. So this parent has 3 children. Messiness are 4, 5, 6. Weights are 2, 3, 4 respectively. Now what happens? So the height is 9. I mean the inconvenience is 9 plus 2 plus 4. No. 9 plus 4 plus 2 times 3 equals to 13 plus 6 equals to 19. Yeah, 19 is the correct answer. RTE? Why is there RTE now? Oh my god.
I'm getting crazy.
Yeah. So many mistakes. Oh,
I still don't know what is wrong with my warp code. It still says the wrong thing.
Can you share your screen again?
I'm getting crazy. Seriously, I am.
Already. CRDP0. Oh, why do you say DP0?
Huh?
Oh, you go from the back. You go from the back. That's interesting. Oh, top bottom approach. You are using top bottom approach. Okay, for current equals to current plus DPI plus 1. Eh? Wait.
But it's still wrong.
Let me arrow. Why did you do this? Why did you do current equals to current plus DP? I see, never mind. Current starts with 0. Yeah, that makes sense.
Huh?
So then current times, wait, don't you need to bracket current times count? Right? Or else it will be
Doesn't make any
count.
difference.
No, it does.
Really?
It does. Yeah, because if you didn't use the bracket, then it will be current multiplied by count modulo mod. So count has been modulo mod, but not the
So this is okay already?
wait. So DPI equals to current.
I actually think so. This is correct.
Current equals to no. Current is your current sum, right?
Yeah?
Yeah. So that means current shouldn't include your multiplication process.
Oh,
Yeah, you can just do DPI equals to current times count modulo mod, right? And then current plus DPI.
times this?
Yeah, modulo mod.
Like this?
Yeah, modulo mod. You bracket current. Yeah, you bracket this, and do modulo mod because it's to modulo mod.
Wait, yeah. So like this?
Yeah, like that. And then you need to add the DPI to the current sum, right?
I'll do it the next round. What?
Oh yeah. Yeah.
So this is okay already?
Yep, should be.
Let me try. 3 should be 6. This should be 6. Yay. Again? 4? 18? Is this 18?
Yes, it is correct.
Are you sure it's
One-
18?
Yes, it's 1 to 6, 18. It's correct.
Yay. You know, I'm getting crazy at this thing.
Yay.
God, like 100% crazy at this needed thing.
Uh,
Now what are you
Yeah.
doing?
I don't know. I'm trying Yabit meetup. Subtask 1 should be simple, but
Have you solved subtask 1?
of what?
Obviously of Yabit meetup.
No.
Not even subtask 1.
Not even
Hmm.
subtask.
How about Skyline?
Oh, Skyline subtask 1, yeah.
How about 2?
Subtask 2, no. Subtask 2, just looking through all permutations would work, but you have to check if it is valid with the conditions. But that is what I don't know how to do.
True though. Does the time complexity allow? Oh wait, it does. It's only 8.
Yeah.
Okay, yeah, a bit meta. I just looked through at this thing and it looks as if Even the first one isn't very easy.
No, the first one is easy. The first one is actually easy.
Huh?
It's very easy to understand the trick.
Maybe I should try Skyline while you try that one.
Yabi kita. Okay. You try Skyline, I'll try Yabi meter.
I try subtask 2.
All right.
What?
Hmm?
For Skyline, I tried subtask 2. What's wrong?
Yeah.
It
Yeah.
is easy what? Just
Yeah,
brute
yeah.
force. Brute force everything.
Yeah. Yes. Yeah.
I could use next permutation, right? I've heard
Yeah,
of
you
it.
can. But if you want to use next computation, you have to do like this. Do bracket, then whatever you want to do with the permutation, while next permutation. Yeah, because then you'll do the next permutation
I must
after.
use next permutation.
Yeah, you can do it like this. This is what I think. You can also just do while something, while true. Then
Like where is it? Oh,
like-
here. I'll just get my code and yeah, I guess this is okay.
Yeah, beat me. Okay. My God.
What are the limits? Skyline.
So I repeat I until n plus y and do that.
It says that there are many possible permutations, you know. There
Yeah.
might be.
There are 4,680 maybe. No, never mind, that's too little. 40,320. 320, yeah. If
No.
mi plus this is so pos is the position. Pos is the position in m. So if mi plus ti plus n. Oh wait.
What?
Oh, never mind. It's not. Yeah,
Huh?
I'm not doing Skyline. I'm trying Yabit Meetup, right? Yeah. Oh wait, where's Yabit? Where's the Yabit? Numbered from one to Y. Wait, then what is this? 4 to 5, 1 to 3, 4, 1 to 3, 4, 5. 1 that's 1 to 3, 1 to 3, 4, 5, 6, 7, 8, 9. Yeah, just including that. So the first one will always be I'm so confused. Why am I so confused? So Wabit 0. Wabit 0 has the parent -1. Wabit 0 does not have a parent. Which means that if n equals to 1, let me just input the lm pause 0. And then if n equals to 1, then that means everything points to that 1%. Everyone is a Yabit except Wabit 0. Which means that the answer, I can set answer equals to 0. Means answer equals to 0. Then I look through rep I, Y. Ans plus equal T Ti. Just Ti. No, 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 no. For I1. For I1, Y1. I1, Y1. So I start from 1 until Y plus 1. Okay, this is getting confused. It's 1, 2, 3. 1, 2, 3. Yeah.
Oh my.
Yeah, what happened?
Oh my God.
Let me change the same as Wabi. Oh. Oh, let me change the same as Wabi N plus J. Oh, Yabi J is the same as Wabi N plus J. Oh, okay, see. So that means since n is equal to 1, I can do for I from 1 until y plus 1. Since n is equal to 1, I can n plus 1. Okay, y plus 1, never mind, same thing. N plus equal ti, then ti. N plus equal ti, yeah. What if, no, I think I can just do rep iy. N plus equal ti plus 1, right? Then after that, what happens? Oh, I get the minimum. Yeah, minimum. What's equal to 0? If if I if not I continue, then if mi messiness level, if messiness of house I plus time taken to go to the house, which is ti plus 1, is smaller than m pos plus t pos plus 1. Pos equals to 1. Your ans plus m pos plus cheapest. Forgot something. Times y. Times y. Times y. Yep. Okay, that's if n equals to 1. Everything's long around. Nope. This should be backslash n, because why not? Okay, that is if n is equal to 1. Now y. Nope. What? Hmm. What? What could possibly be wrong about this? What are the edge cases? If the edge cases are y equals to 1 and y equals to 500,000. Y equals to 1 and y equals to 500,000. Right? What happens if y equals to 1? If y equals to 1, then there is 1. Just one bit. One bit, one elder. Right? Then it should be simple. If y equals to 500,000, should still be okay. Yeah. What could possibly be wrong here? Hmm. It's interesting. Hmm. 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 What's the progress, Civilian?
Still trying to get the if valid function for, my best thought is O n cube function, O n cube, right? But it doesn't matter because n is 8.
Yeah. I'm so confused. Zero. Wait, let me read the question once again. Once more. Very peculiar. N plus y. What bit I don't really think so. So that since what bit we one. 1 to y is same as n plus j.
Any progress?
There are two corner cases. Wrong one. There are two corner cases. First up task one. I can't seem to find them. Yeah, it's all. It's okay. Let me try if y is equal to 1. Let's see if y is equal to 1. So this is if n equals to 1. This is then next is if y equals to 1. If y equals to 1, then hmm. If y equals to 1, hmm. I can go from let me move. Okay. They will be guaranteed to fit in a 64-bit integer. That's long line. Confused. Alright. I am very confused. What? What if y equals to 1? Mm, each of the n meetings. Oh. Oh. and they can be equal to 0. Pi can be equal to 0. If it's equal to 0, then it's not constant. So, down. Oh yeah, it works. Okay, why? If y equal is y equals to 1, y equals to 1, the y, the only one, what yabit will go to each of those. Oh, but you have to check if it is a parent. How do we check that it's part of the 3?
Đâu, để suy xem không? Ừ. Thế thì chỉ cái gì mà?
So what's your progress on Skyline?
Not very good.
Have you solved Satas 2?
Not yet. How about you?
I've done 1. Satas 1.
I never expected it was this hard.
No. Satas 2. What if y equals 1? What if I represent this as a DSU? Like a DSU. How do I represent it as edges? How? No, edges will mix. Yes, you mix. Yes, is too much. Yeah, why would we use yes? Why would you use yes? You edges would work. Yeah, edges would work. Okay, let's try use this. So we have the vector of vector of long. The realize edges. Okay. This edges. Ooh. No, but it's a 3. I think it's better for the yes. So we have PI and P9. We need this as a vector of PNN. Vector of PNN. So then edges dot push back. No. If PI equals -1, continue. If not, then we have PI is the parents of I. I is orbit 1, orbit 2. Yeah, I think I know how to do this. Just how do I implement it? Oh my god, how do I implement it? That is a good question. So basically, what we can do is we have this, and let's say we have 3, and here, disconnected here, disconnected here. Then we have the
那用的爸爸错吗？
对。
他爸爸肯定没错。他爸爸没有错。
不管他。
不要急，不要慌。
没有。
1, 2, 3, 4. Yeah. So we can do this like a recursive function. We'll start at the root. No, we start at the bottom. We start at node n. Start at node n, then you find the answer for n, and then you check this and then which one is the right. Yeah. Yes. Since it's a tree, then everything could be filled out. The tree where its leaves already has the answers. Then yeah. You can do it like that. Right. Just like that. But how do we implement it? We can use a struct. We can use a struct. Okay, so that's the plan. That is the plan. So we have the struct containing use node, but the problem is this is not a binary tree. So we will need we want the parent. Oh my god. Oh. We cannot have two parents. Right? Let's assume everyone is in one tree first. Yeah, everyone has to be in one. Some people don't have a parent. So first, 1 hour we can see this. First we have the edges here. Let's try this again. So we have ln y in n in y. Then we have the vector of vector PLN edges. Which we have this, right? And then we just loop through. Repeat I till n plus 1. Int p and t. In p, in p, and then in p. Then that's the pattern of hi. So edges I dot pb with p, yeah. Then vice the reverse. Oh no, it's better, yeah, it's better to not have reverse. Oh, I haven't. What? No, it's correct, right? Oh. Okay. What? What? Got push back. Oh, actually, this is still wrong. Make that. Maybe make that. If pi equals oh, oh, let's the pass. Not expanded from the one. No, first. Oh. What? Don't understand. What? Oh, I see. Oh my god. Oh. Okay, so I have the address, and then now I get the messiness levels. get VLN and repeat IY is equal to Y plus M is equal to Y. Hmm. MI still in wrong direction. Seen MI. Okay. Repeat IY seen MI. Try the edges of M. Then I start with that. Okay, now the problem is how do we find the bottom? I think yeah, I think I know how to solve Yabit meetup, like the whole thing. I just don't know how to implement it. Oh god, how do I implement this? I am so confused. I am so confused. Ah, huh? How do we find that? Okay, let me go back to what I wanted to do. Do this. All right. Then equals to 1. PMC, VLLP, VP, 1, equals 1. PI, 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 PI. A vector of vectors of vectors in a vector of a vector in a vector of a vector. If y y equals to 1, then Oh, if y equals to 1, then we just traverse through the list. We traverse through the parents. Right? If y equals to 1, we traverse through the parents, we get. How do we traverse through the parents? Okay, so what do we want to do? We want to traverse through the parents, and for each parent, while we traverse through the parents, we take notes of the current answer. When we traverse to the first parent, that is the parent of the only a bit, then the answer is the distance, the time it takes for the yabit to go to the to the parent and back, plus his messiness. Which is weird because no one's going to his house, so I don't know why he would be embarrassed. Unless he contemplates his choices. Anyways, we look through the yabit, we take the current answer. And when we traverse through the parent's parent, then because there's only one yabit, this is basically a straight line. It's basically a straight line tree. A tree with only one child node for each parent node. Then when we go to the parent's parent, we add the answer with the distance it takes to go to the parent's parent. Yeah, and since this is a tree and not a graph, I cannot. Yeah. Okay. So we have the current. Current in equals to 0. Current equals to y. Current in equals to n plus 1. And equals to 0. While current in, okay, while true, what do we do? We have the current end of which we are at the current end. We know it's parents, so we find the distance between the parent and this. Yeah, okay. So we add the distance current in times 2. Right, you go there, go back, plus t card in times 2. Rest will always have card. Let's go t card in times 2. Then calculate ans current in equals to p current in. So ans current in is current int. Ans int is now, because it's a parent, ans int equals to res. Ans int equals to res. All right. Then we have that. Since ans int equals to res, we already have the ans while p int not equal minus 1. Then for rep I ans ans. Okay, this is if y equals to 1. Let's leave this case. Let's say there are 3 NOI. Where's the pen? So first would be minus 1 0. Y be 0. Then there would be 3 people. There are 2 others. There's this guy, and there's this guy. Pointing. Right. Then there is the Yabit. Let's say we have this guy first. This guy, his parent is index 1 base. Oh, it's 1 base. So yeah, it is 1 base. I can just decrease it to become 0 base, because who likes 1 base when everything else is 0 base? Pi minus 1. Pi minus. Don't even need edges here. But I can use it next time. Never. What happened? Oh. It is 1 base. If Pi is 0, it becomes minus. Why is this question so confusing? I'm so confused by the format of the input. The next n plus y lines, and then the icon is I 0 based or 1 based? I'm so confused. In n equals to n plus 1. Rest equals to y is int n plus 1. Oh, yeah. Yeah, that's why. N plus y is comfortable. When p int that equals to minus 1. Is it 1 based or 0 based? They're saying bit 1 has no parents. But that's bit 1. So it's 1 based. Which means that that means that guy is bit 2. So I can say this points to bit 2, weight is 4, for example. So this is bit 1, this bit 2, this bit 3, this bit 4, this is the Yabit. Yeah, right? That is the Yabit. So then this guy is pointing to 2 with a weight of 4. Then I want someone pointing to 1 with a weight of 3. Oh wait, no, that's Yabit 1. So this has to be Yabit 2. So Yabit 2 is pointing to 1 with a weight of 3. This is pointing to 2 with a weight of 4. Then 4 is pointing to 3 with a weight of 2, 3, 4, 1. Then we have 3, 1. The weight is 7. Let's see if I wish. Want to win the output win. Zero 1 0 0 1 0 1 0. I got it. I can't even think. Huh? Wait, what? I am so confused. N plus y. You gotta be n plus y. It has to be n. So in is because it's 0 based. It has to be n. And then it will be an infinite loop. Because everything is an infinite loop. While p in not equal -1. Rest plus equal p int times 2. Int equals to p int and int equals to rest. Int equals to n equals to 3 or 1 2 3. P int is 3. What could have gone wrong? Why is it 6 turning? Why is it 6 turning? Actually, why?
Sorry, hả? Còn cái căng đó.
Why is it timed out? Is it the while loop? Yep, it is the while loop. Which means that... Oh no, it's not the while loop. Oh, it is the while loop. See?
Okay, come, let's go. Come, let's go outside.
I am so confused. Why is this? Yeah. Yeah. I think I know how to solve the bit later. Fully. I have an idea, but I can't find it.
Explain the problem. I can draw in my mind. Yeah, bit me up. Okay.
So, the problem is this, there are n plus y, the n plus y wabbits, right, in the village, the family tree, right? Family tree, right? Yes, there are n plus y wabbits.
Okay.
Each wabbit has their own house.
Okay.
Right, so we can draw this, right? And this is a tree, we can have like this, right? Right.
Okay, you are given a 3.
Yeah. Now there are y. There is another type of wabbit called yabbits,
Okay.
and there are y yabbits in this family tree.
Okay.
And the yabbits are basically the leaf nodes,
Ah, okay.
right? So that means in this case there are n is equal to 2 and
Ah, okay.
yeah. So you are given this road, this path.
Which part?
For each node, for each wabbit,
For each node.
for each wabbit, yeah.
For each node. For each node. Okay.
For each wabbit, you are given its parent.
Okay.
You are given its parent, and the time taken for that wabbit to walk the parent and vice versa.
Quite okay. That direction.
By direction. Yeah, right.
Uh-huh.
So for example, if I just put the random numbers 2, 3, 1, 4, 5, right? Then this is an example, right?
Yeah.
Then you are also given the messiness level of the houses of the yabbits. Yabbits don't like to clean up, so it's just that messy.
Okay.
Right, so it's a and 3, 1, 7, 6, right?
Okay.
Only the neighbors. Okay.
Okay.
So a white rabbit wants the yabbits to meet up.
Okay.
So for each of the n nodes that are not leaf nodes,
Yeah.
right? You will make every yabbit that is directly or indirectly a descendant of that node X,
Yeah.
right? To meet up at X,
Okay.
right?
Okay.
So they will take this time to go to X.
Total.
In total, yeah. Then they will choose
Total or max?
total.
Okay.
Then they will choose one of the yabbits houses
Uh-huh.
to go to after that to have a party.
Okay.
So that they live together, right? For example, I this one. Right?
Okay.
All 3 of them will go here.
Why?
Because all 3 of them will want to meet here.
Why? So this messy.
Oh, no.
Because
No. It's just this is an example. Let's say this is here, right? Now, white rabbit wants for each X, right? For each node X, white rabbit wants the meet up to be as least convenient as possible, as least inconvenient as possible.
And what is
And
the
what is the inconvenience level? So for each it takes 2 seconds like this to go here.
Yeah.
2 minutes, 2 hours, whatever you want, right? For every second that it takes for them to walk, their inconvenience level increases by 1,
Okay.
right? And because there's a messiness level, the yabbit, the owner of this house, right, will be embarrassed that this house is messy.
Yeah.
And his inconvenience level will increase by the messiness of his house. Messiness level of his house.
Everyone who go to that messy house or
Only the
okay. So it's sum of the edges plus the leaf nodes value.
some of the edges plus difference value plus this specific edge
times
the number of bits that are
Okay,
descended.
and then the question is,
Question is, for each x, right, what is the least common x? For each of the non-leaf node x, what is the other name? So first, all the bits will go to x, right? Here or here, wherever, right?
okay, so let's say if that node says have one children, one child. Does that mean the root node is not a place for, so root node is not used at all? In this case? This one, yeah.
Oh no, it will be used.
Oh,
Because you want to find the least inconvenience level for if they meet up at each of these, right? So if they meet up here, what's the inconvenience level? If they meet up here before going to the house, what's the inconvenience level?
Okay.
Right?
okay.
Yeah.
So you need to calculate for every non-leaf node.
Yeah.
You need to calculate for every non-leaf node. So is it query or what? Like, you can query with the number of, with the node ID or,
No, you have to print every.
or you have to print it?
Yeah.
It's not interactive, yeah?
Print that.
For every non-leaf node. Okay. But it's the minimum already, right?
Hmm?
For every non-leaf node, you need to print the minimum, right?
Yeah.
So for sure the oh iya bisa juga ya, maximumnya bisa ini ya. So you need to calculate everything ya. Apa berarti? Ini nyambung jarum. Nyambung jarum tidak. What is the constraint? What are the constraints? How big is the maximum size?
N is at most 500,000. Y is at most 500,000. The time taken, the edges weight is at most 1E6, and the messiness level is at most 1E12. It is guaranteed that the answer will fit into a 64-bit integer, which is basically a normal.
Eh,
还在继续啊？他做完了是吧？
还没有，
他在这干嘛去了？
还没跟他爸爸说。
他们两个你一个不公平的，哎，我帮不上忙啊。但我跟他现在没领先多少是吧？
对
他就领
呀
先4分而已。
不对，这个，
Okay, you wanna solve this one?
那你怎么没用 VS Code 用这个来用？
The idea?
The idea is, we will start at this node, for example. This is our first node, right? Right?
Yeah.
So what we can do is we find the answer for this node,
Okay.
right? And then that is like recursion. So the answer for this node over here, right, is the same as the minimum of the answer here, right, plus this weight multiplied by the number of your bits, right, plus this weight. Oh, no, never mind. It was unique.
Well, messiness makes it harder.
No, you can actually just store the total distance level as a distance level.
Anyway,
There will be weight.
then walk to that. What? So I asked yeah. I don't understand. Ya, pagi. Jelek lah, bang. Wow, udah depan bang. Wow, ayo. Right. Nanti ngomong lagi. Tidak. Ikat apa nama dia? Iya. Di sana, nggak boleh pakai tangan. What? Ini sana. And followed by ya, tadi kan saya Nanti tuh, nanti jam berapa adiknya makan itu? 2.
How do I do this?
Sebentar tiga mau apa?
Hmm.
Hah? Kau ada kemana?
把这个放这里不？
啊？
把这个放我的这里吃呗。
这个我看你要打一个。Cái điện là có mặt có gặp.
Oh, n times 30. So the DP total is two-dimensional, ij.
Yeah.
Oh, no, no, it's not. It's not. Oh, it's not.
Oh, since when did you have so many pens? Yeah, since when did you have this? Yeah, when did you have this?
Yeah, that's my pen. I have many pens. So you got two arrays.
那ดูกันแล้วดูหมูกอดเลย
今天的题目太难了，是吧？啊，
勉强做出来一个题了，
做出了一个了，哪一个？
勉强。
70%是吧？
嗯。
刷新看，哎，它怎么不显示分数？奇怪，
不管了。
还有40分钟。好嘞，70加10 80分，它也是一样是吧？它这比你多4分，另外一个题目做了4分，另外一个题目你有做出来没有？
没有。
你暴力可以搞4分不？你可以啊，你可以试试看暴力能不能搞4分是吧？分数一样的。
很点啦，就我这样的啦，搞完了吗？啊，还有4分钟，不用管我，不用管我的。
Hmm.
Yeah, I do not know how to solve it anymore.
How was it? I still don't understand what is wrong with my code.
Can I see it?
Okay. This is the code.
For which question is this?
Skyline, of course.
Oh,
Look at this whole bitch of its valid code.
I see.
Main function is like that.
I understand. While not is valid, next permutation answer within us. Try. I don't know if this is the correct answer. but in the while loop, the while not is valid. Instead of doing that, try do bracket. Wait, let me type it out. Let me type it in chat. Do
Okay.
bracket. Wait. Wait. Notes.
Do what?
Wait. How do I type? Okay, I see. So do while what you call next permutation as the begin. Next permutation
What do you mean?
begin answer and yeah, like that. Oh my god. All right, let me try skyline also. I just task 2. All right, task 2. Task 1 is fine. Who's at task 1? Maybe there. 2. Will is valid VI. VI, then it means I need to global. Means that I will have this, it means that and it means that until this, it means that it equals to that VIN. Which means that is valid parenthesis VI. How do we do this? Oh, I can do. Ah. So first this one we're checking L should be -1. There is guaranteed for that to be a valid permutation, which means that L0 has to be -1. And rep I, which means that we can do this for I1 and 1. Right? Then so max val equals to V0 and max pos equals to 0. However, we can make this even simpler with pos, as if we only using the pos, as we can access the max val using the position for I1 and 1, which means for 1 to n -1 if Vi is smaller than V pos. If Vi is smaller than V pos, then that means that I don't know. If Vi is smaller than V pos, if Vi is smaller than V pos, then if Vi is smaller than V pos, that means V pos has to be the next thing. So if Li equal to pos, if Li is equal to pos, then okay, so if Li is not equal to pos, then return 0 because it's supposed to be equal to pos as Vi is smaller than V pos. Now, if Vi is equal to V pos, if they are equal, then what happens? Do we really care what happens if they're equal? Which means the one larger than should still be pos. Oh, it cannot be equal, yeah, because it's a permutation of one of them, which is that will be pos. Else, that means if there's an else that means this vi is greater than v pos. If vi is greater than v pos, then we have to check if ni not equal minus 1 greater than 0. Pos equals to n minus 1. Now reverse for reverse wrap. Does it start with it start minus 1 greater than or equal to a. Has to be reverse form. I want to put on. I want to start at n minus 2, which means that the should be n minus 1 and then is better than 0, which actually means that reverse wrap would make sense. That will be. Does it mean that wrap should also make sense? Because it is not the best make sense. If vi is no, what about you? If vi is smaller than v pos, if vi is smaller than v pos, so going from the back, it means that if vi is smaller than the current minimum, let's look something. If vi is smaller than v pos, if that is smaller than v pos, if that one is smaller than v pos, wait, what am I saying? Oh, if this is smaller than v pos, then v pos will be if if ri not equal pos, it's on 0. Else if ri not equal, because this is so vi is greater than p pos, it means that this is greater than that, so it has to be minus 1, so it has to be less than 0, then replace pos equals to I. Return 1. One to two lines. Oh my god. There's only one correct answer, and there's only one accepted case, and this is the similar to the case. Oh, but this one's CPP though. Wait, what? There's a CPP though, CPP. What? Mm, 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 mm. Mm. Mm.
You're not writing down the answer.
Why is it always going to Arabic? I don't understand. Should you learn to learn to
Okay. Done as well. Let's see, read.
did you got your skill?
I shall.
You should
Question five.
learn this thing. Hmm. Oh wow. Mhm. That's it. Why is it that? We want to the most lexicographically minimum number. What's your progress, Chinwillian?
I still don't understand. What is wrong?
Yeah, I'm also trying Skyline subtask 2.
How was it?
I only got one test case correct.
Me too.
What's your method? How did you do it?
Me?
Yeah.
I just use next permutation. You found all the possible permutation and use is valid. Yeah,
And
very simple.
yeah, but
But
what
very
did
dumb as well.
but what does your is valid do?
You just go for every number in this. We just go to the left and go to the right and see which is the
Largest.
first highest first
First largest.
number that is greater than it, and then
I see.
just and let's check whether it is just like what the what they recorded.
Oh, I see. Yeah. I did something similar. I did something similar. Yeah, similar. It's just my valid function. Instead of doing it manually for each, I have a prefix max. I have a prefix max and a suffix max, technically. Yeah. So what I do is if I look for L first. I look for L. See? So I look through the array. If VI is smaller than V of the current greatest V of the position of the current greatest height of the building, right? If it is smaller than that height, if the height is smaller, then that means Li should point to that building that is taller, right? So if Li is not pointing to that building that's taller, then I should return 0.
Yeah, true.
Oh no, this is wrong. Never mind. Yeah, I found out why this is wrong. It could be like 5, then 4, 3. 5, 4, 3. This counts it as correct. 5, 4, 3 5, 4, 3 may be correct, right? But they may not think so. Yeah. Never mind, my method doesn't work.
But the thing is that I already coded this out and I don't know what is wrong with it. Just now I already told you, right?
Yeah.
And I already changed it to do and do one, but it's still wrong.
Still wrong. That's confusing. How much time do you have left, Chen William?
Well, 1 minute.
Wow,
you?
that's 30 seconds longer than how much I have.
Wow. I
How much-
started a little bit later than you then.
Yeah.
I'm just staring at this. I don't think we even have to do anything.
Yeah.
Just
So
there.
how many points did you get?
81.
81. Oh,
I know you got 4 more points than me because I didn't try Yabim it up.
yeah, I been meet up. If you tried it, just subtask 1, you could have gotten it. Subtask 1 is very simple.
I don't care. Yay, it's over.
Happy New Year.
Oh, Happy New Year.
New contest. New contest. Oh.
Yay.
I can't. Please. Wow.
Lol.
Wow.
Oh wait. Since the contest is over, I need to ask you something.
Yeah.
You see, as I told you in Gmail chat, my VS Code studio cannot submit to Catalyst.
Oh, this one?
Yeah, you can't submit to Catalyst. Cannot.
Yeah, wait.
Like when I press the button, it says I need some like configuration file or whatever.
Yeah, I haven't. Wait, let me try. Let me see. Katis. You said Katis?
Yeah.
Katis.com.
Just get a random hello world problem.
Take him there. Oh my god, I haven't done hello world. Just kidding. I haven't login.
Seriously?
Login. Ding ding. Your VS code, this one, this doesn't work. Is that what you're saying?
Uh-huh.
Okay. Let me try submit something I've already solved.
You just press submit on Catalyst.
Okay, let me try submitting something I've
Alphabet stand. That's what I did.
Katis is very different from last time. I prefer last time's one. Like 2 years ago's format was much nicer. When you look at the problems, oh my god, it's so hard to find problems like this. I don't like it. Anyways, what? Oh yeah, this
Just
one.
press submit on Catalyst, try.
Okay, we try submit on Katis.
Yeah, that's what I know also.
Yeah, it works.
But for mine doesn't work.
Try. You try. Share your screen.
Okay,
I need water.
where is it?
Yeah. Just share your screen first so I can see everything.
Okay. Share my screen. You see it's the VS Code here. And stop this. Wait, why can't I stop?
Press something else and then go back. Like, press another tab, like the
E.
yes. That,
So I press, wait over here you'll find the, where is it? This thing blocking the way, go get away. Yep. So it's called tracking shares. Found it? It's here, right?
Yep.
You go to the submissions. You just come here already, right? And I go to the VS Code. I press submit on Catalyst. I already pressed already.
Try clicking. Try pressing this. What's this?
Please ensure. Where did I click this? This?
Yeah. Maybe.
It says configure notification.
Yeah, maybe the arrow first. We'll see. We'll extend the message. Present in users cwl.katis submit.py. Try here again. Configure. Yeah, just press that.
This?
Yeah.
Oh.
Go to the sun maybe. Extension settings. Wait, let me see my to submit to Katis, you need to have the submission clients and the configuration file downloaded in a folder called .katis in your home directory. Submission results will open in your browser. Let me open my terminal cd dot dot okay, cd.katis ls submit.py code submit.py. What is that?
What is it?
Again?
What?
Open terminal. Try open terminal. Command J. Command J. J for Jamaica. Try Command J.
I've already pressed Command J.
Click outside the text box for a while. Click outside. Anywhere. Oh, here. I don't know. Yeah, now to Command J. Try Command J.
Ooh.
Yeah. Then terminal. Press terminal. Type cd dot dot Wait, I wonder, can we do CD? Oh yeah, yeah. CD. No. Never mind. Try CD space grave sign. Oh no, grave. Like beside your number one. Beside number one. Hold shift while pressing that button. Yeah, that right. Slash. Yeah. Dot Katis. Tab. Press tab.
Tab.
Yeah, tab.
I pressed it.
Okay, now just press enter. No such file.
Hmm.
Yeah, that's the problem.
Interesting.
Now try CD, just the grave sign. CD space, then just the grave sign.
Oh wait. Huh? What's next? I don't get it.
Yeah, you got it. All right. Wait. Let me see. Competitive programming helpers. You hit. CPP, GCC, Java 3.7.2. Okay. LS. Type LS. Enter. Let's see what's inside. Enter. Just LS, then enter. Yeah.
No, Apple is not. It's not enter. It's return though.
Yeah, return. Yeah, return. LS. Enter. Where do you put your stuff?
Huh?
Is there dot Katis? Yeah. You put that. Stop playing the game. Stop playing the game.
I also don't know. Look at the finders.
My own problem here.
I also don't know. Like CWL. The whole stuff is here, and I don't know what is going on. When I search Catis, are there? I don't know what these two are.
Click. Can you open this?
Which one? This one?
Yeah, done. Yes. Yeah, it's fine.
This whole shit came out.
Yes. This is, yeah, see, that's what I have also. What's the path to this file? What's the path to this file? You know what the path is? In the finders. What's the path?
Finders.
Yeah. What's the path?
Wait, I just search Catis first. How do I find the path?
I have no idea. Maybe it's here. I do not know.
It's like
Get
I
info.
know on Windows you can.
Try get info. Size where
Wait, here.
Macintosh HD uses.
Oh, now I get it.
It's in downloads.
Yeah, it's in downloads. Are they?
Why is it in downloads?
But how do you move to something called .catis?
Try make a folder.
Where?
Just right click the empty space at the bottom. Yeah, new folder. Because for me, in my main directory.
What is the name then?
Huh?
What should be the name?
Try .catis.
.catis. Oh.
Okay.
The result for the system.
Okay. That means
That's a bit awkward though.
How do we Mine works. It works for me. CPP.
Does your one have a .catis folder?
Yeah, I have a .catis folder.
How do you get it?
for I don't know. I don't remember. Let me see. Dot catches. Dot cat.
How did you manage to get your dot cat this folder?
How do you get dot folders? Get dot folders. Oh.
Yeah, I wonder. Very much indeed.
Open File Explorer from the oh no, this Windows.
File Explorer is in Windows. Apple is Finder, I guess. Apple is a lot different from Windows, man.
Yeah, it's better.
I'm not familiar with this system yet.
Dot catches. Dot catches. Just catches. Catches is this one? No, that's not it. Oh, is it this one? Oh, wait. Catches CLI. Catches. Wait. Yeah. Catches online judge command, right? Then runs both in Python 2 and in Python 3. Install the client.
Huh?
Git clone to clone the
Can you share your screen?
CD on into the and run Python. Okay, let me share my screen. So
What is this?
for this, right?
What do you do? Cat this.
I've cut this.
Yeah, I found a bunch of stuff.
Yes, and where was it? Cut this CLI. I have cut this CLI, and this is basically what runs the submission. See, cut this online. Install the client. The also continue.
But I don't have.
Yes, you have to do this, I think. To run the client, CD into the client and run Python.submit.
To run the client.
Yeah, try this. Try typing this. I'll
Just put it in the chat,
yeah, I'll put it in the chat. Okay.
I guess. No idea what's that. Yay, I found it.
Oh, Genie. I forgot about Genie. It's been so long.
And who is this guy? Hette CLI.
Yeah, you got share your screen. Share your screen, please.
Okay. Share my screen. Share. And no, it's not the wrong one. Are there?
Oh, you press the link.
Link? Where got link?
You see that text over there?
Here?
Run clone.
Uh-huh.
Yeah. Just copy paste that. Copy paste that. This. Yeah, that. No, until the git clone. Until the git clone. Yes. Yeah. Copy paste. Copy command C. Just command C. Yeah, you got it? All right. Then now open terminal. Open terminal. You know how to open terminal? Just,
Yeah, you told me.
command-
Don't have to open. It's already open.
Oh, that okay.
I didn't close it.
Then just paste it there.
Uh-huh.
I think it's better if you do not use this. Okay, never mind. Yeah. Enter. Return. Yep. Should be okay now. Try
What is
submitting.
this?
Try submitting something. Where is it? Here. Try something. Open one of your files.
Tracking shares. Uh-huh.
Try
Yep.
submitting. Try submit.
Let me see. Sorry, wrong page. See, nothing happened. Refresh.
Yeah, it doesn't work. There's something. How do I?
You see, this is submitted by me yesterday, not today. Interesting. Very interesting. Let me look at the finder part. And I still don't have the dot cat this part. Do you have? Wait.
Yeah, I do.
Wait, I see something here. You see it? This
Oh,
one.
yeah. Yes, yes.
And then what do I do with it?
Try opening it. Open it. Open it.
I got a bunch of stuff.
Press the Katis. Press Katis.
Uh-huh.
Yeah, press. Double click it. Double click it.
Oh. Can you
And-
run the terminal?
Enter. Enter. Yeah, this is the Apple terminal.
I know, this is the terminal.
I think in Windows it's called command line. I think in Windows.
Don't
Yeah,
care about Windows.
Yeah. Should be okay.
Uh-huh. I pressed return already.
Yeah. Never. I don't know. I do not know how to fix this. What if we try? What if we try putting the file manually? How do you make a? How do you
What do you
manually?
mean? Okay, what do you mean here?
For me, right, in my main repository, I have a .katis folder that has submit.py.
But the submit.py here is in something called Katis.
Yeah, Katis
Yeah. See, the submit.py is here.
Katis client.
And as well as in downloads as well. Yeah.
Open
One more extra. Don't know why it's here. To be for this extra one. Bye.
Mac OS.
For Mac OS.
To do that, open the file in the text editor, export. CLI.
Why this?
Now you can run the guidance. You might need
Yeah. Binning everything.
user desktop.
Huh?
Export path using user desktop at the end of the I don't know. I do not know how to solve this. Yes. Oh, but Chen William, does the submit button work for other coding platforms? Is it works
What do
for
you
other coding platforms? Try Code Forces. Try Code Forces. Does it work on Code Forces?
I don't know. I haven't tried yet.
Should work on Code Forces, I think. Let me check. But I think for Code Forces, you need to open Firefox. Yeah, try
Okay.
Forces.
I'll try the easiest one, like what I did. Like watermelon.
I think you need to
What do I do?
think
And I got watermelon.
press submit.
I have to-
Just code very simple. Watermelon super simple.
what do you do with watermelon? I didn't
Uh,
even look at the question.
oh, you can't use bits.stdc.
Oh yeah.
Yeah.
Let's use IO stream.
Ice cream, just ice cream.
No, CSTIO. I like it.
Oh, you like CST?
Bored. I'm very bored here.
I prefer iOS stream, but
Because I don't want to type out the username
Yeah.
stuff. So blah, blah, blah.
but before this, can you go back to Code Forces?
What?
Yeah, just go back to Code
What
Forces.
is wrong with Code Forces?
You don't have an account yet.
Oh,
Submit button won't work. Scroll up. Yeah, see, you don't have an account.
register. What does enter means?
It is basically sign in. You have an account already. Okay, now.
Use Gmail. Yay. And I signed in. Yay. It's me,
Oh, okay, you got
young
it.
guy.
Yeah, then try submit again.
Watermelon. Yeah. What is the question again? I don't even know.
Is it even or not? That's all.
Oh. That is easy.
If I'm not wrong, that's the question. Or maybe I forgot something.
Oh yeah.
Percentage S. No, yes.
Why is it?
I think you got it switched.
Why?
Look at the question again. Look at the question again.
And then why does it say expect a semicolon?
Wait, let me see. Why does it expect a semicolon? Maybe put your else on top of the. No, it shouldn't matter. I don't think it matters.
Nothing happened.
Oh yeah, you don't have a semicolon after plain F.
Oh yeah, I'm very dumb. Run all. Huh?
Plain F no also. Can you go back to the question?
And I just press submit. What the heck is this?
Yeah. So for code forces, it's special because for some reason, CPH submit doesn't work with Google Chrome. So you need another browser that is compatible. So for some reason, for the CPH submit for code forces, Google Chrome is not compatible. It's not a compatible browser.
How about
So
Safari?
you need another browser. Safari maybe, I don't know. But for me, I use Firefox for me. Firefox works. I don't know. Safari maybe works. Let's see. You can change.
I like to use Google Chrome.
You don't like what? You don't like to use Google Chrome?
I like to use Google Chrome. I'm very suited to it.
Yeah. Let me see.
It's good.
Hmm. Use Google Chrome.
Having a rest right here for no reason. Oh my god, this might be too loud. Nope, no music. Yay. Wait, where did you go?
I think we should stop the live stream for now and then just.
I'm gonna die. Yay.
Do you want to stop the live stream?
Okay, it doesn't matter, right? Because right,
It's just the current topic is now unrelated to
yeah.
the title of the stream.
How true.
So do you want to stop the live stream?
Okay.